This is my second iteration of a surgical continuum robot.
You can see how it works over here when I'm using my hands, but eventually I'm going to create a pulley system with motors to do this autonomously, but right now it's just me pulling the strings to show how all these three parts move, as well as how the end part also rotates. This is something I'll explain later in the video. This is the first iteration over here. You can see the pulley system and how the motors are also attached to the servo driver and the Arduino.
Our previous robot was comprised of two parts. One is the actual continuum robot, and the other is the base. Essentially, what would happen is the continuum robot would be inserted into the base, and these wires would go through the base and attach to these motors over here, essentially allowing us to pull these wires from the base and turn a robot. But like I said, the problem is that it can be held vertically but not horizontally because of the tilt. It's not useful.
Learning from the first iteration, there were two major problems that I needed fixed. One was that the sagging was a real issue because I wanted my robot to be horizontal, and having the robot sag and not having control in a horizontal position isn't going to work for me. I also needed more mobility because having it only move in one plane isn't enough mobility for it to be a good surgery robot. So I got started on CAD and creating the design for the attachments to the spring, but in this case, I did not want to use a spring. I used a Tentacle actual strip. This is a metal that bends in the same way that a spring does, but it's much more reliable and it can only bend in one way. So I attached the designs that I 3D printed onto the Tentacle strip, and if you don't understand this mechanism over here, watch my previous video, I explained it. I also added the strings from the top to the bottom, the 4 strings that I need. You can see the finished robot over here, and pulling one of these strings, one of these 4 strings, moves the robot in a certain way.
It can also rotate from back here, just the tip. This will help us get to any point that we want to, no matter where we are.
There are 2 obvious components that are left in this robot that are still meant to be made. Those 2 components are one, the attachment at the end. That's like it could be a blade, it could be scissors, that kind of, cutting tool, some tool at the end, and also a mechanism that allows the whole robot to be like situated somewhere and rotate and move. Those 2 mechanisms are something I need to work on, and I needed to decide which one was more important for the time being right now, and I decided that the actual base that could rotate and move was much more important. I started taking notes and creating different designs in my head that I could use, but this design from Stanford Charm Lab is really intriguing to me, and I decided that this is exactly what I need to make. And it essentially uses 2 gears and like a kind of rail system, and this allows you to rotate and like move it back and forth, which is like just amazing and everything I need. So I got started in Fusion 360, and the process to get this done was actually pretty tough, but you can see how it kind of looks here. This is just a test for now, so when I know it works and when I can trust that it can handle the full weight of the robot, I'll explain how it works. You can see me here testing both the insertion, retraction, as well as the rotation mechanism of the rail system that I made here. And with confirmation that the rail system that I made works, the next steps are to make it bigger and make it support the whole weight of the robot, as well as make the attachment of the robot whatever I put, like scissors or blade. Anyways, that's gonna be it for today. Stay tuned for updates.